probability distribution given in a probability model or a probability table, and we're going to graph that. So again, I'm looking at trying to find some paper because this thing is going all over the place. I just want to graph this table. So let me draw an axis here, and this will be the number passed out of 4, and I can have anywhere from 0, 1, 2, 3, 4, and this is quantitative, so I don't want to do a bar graph. I want to do a histogram, and I'm going to make my classes so that they straddle. So this is from negative 0.5 to 0.5, and the frequency is 0.036. So wow, that's really small. So this is 0.036. The next probability is 0.132, so a lot taller. 0.132. The likelihood that I get exactly 2 quizzes passed out of 3 is 0.2604. So that's, wow, that's twice that. So this one's 0.2604. Then I have the likelihood that I passed exactly 3 of the 4 quizzes. So we're going to increase this by a little bit. Oh, this is just not an art major, but that's okay. 3, 3, 1, 5. And then the probability that I pass all 4 is about 24% of the time. So a little bit underneath this guy. These are supposed to be all equal size bends in width. 2, 4, 0, 1. This is my probability histogram. So I have probability along the vertical axis. I have the number of quizzes passed out of 4 on the horizontal axis, and this is a histogram representing that discrete quantitative value. Discrete because I'm counting the number passed. The next question was asking me to find, let me just flip and change this. Find the probability that a student passes at most 3 quizzes and shade in this area on my probability histogram. So I'm going to take my probability histogram that I've drawn at most 3. That means less than and equal to 3. So at most 3 is 3 and smaller. So what is the probability that if I'm counting the number of quizzes passed out of 4, that number is at most 3? That's going to be the sum of all of these probabilities together, or I notice I've just left off this 1 bin at the end. Let's use the complement rule. 1 minus 0.2401. Go for the easiest. And so I could come up with the same answer by adding these 4 bins or just using the complement rule and taking the difference of 1 and 0.2401. So the likelihood that I pass at most 3 is 0.759, so 0.76. So I'll just do some wiggly lines for approximately 0.76. So about 76% of the time I'll pass at most 3.